Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. The date for tonight will be November 17, 2024, and the time is 23:31. That's military time. So 23 minus 12, that will be 11. So it's 11:31 p.m. November 17. I'm just reading my assembled digital clock. Okay. My topic for this evening will be a continuation of my long video format topic, analytic geometry, and I am now on lesson number 19. So this is a continuation of my long video format topic, analytic geometry, and this is lesson number 19. Okay, let's proceed. The title of the topic for tonight will be Analytic Geometry Long Video Format, lesson number 19. Oh, by the way, for the past weeks, I've done the so-called short videos on electronic things. So I assembled EM, FM receivers, I assembled many voltage regulators, and as you could see it on my channel on the short form videos, I got some electronic topics over there. So for those of you who would like to see also my topic on the short videos, just visit my channel at it will be at youtube.com/@ProfDavidJ.Delosies. If you would like to see it, I got short form videos on the how-to topics. How-to topics meaning it could be how-to is a procedure, right? So anything that resembles a how-to topic that falls under my short form videos. Okay, let's continue. The subject matter for tonight, a little bit. Analytic geometry lesson number 19, and the title of the topic is this old study of ellipse. The location of the center of that ellipse is actually at HK. The last time around, I discussed the concept of so-called the study of ellipse with center at 0, 0. So for tonight, okay, this is the so-called worst case scenario for an ellipse. Because the first topic is actually at the center at 0, 0. And the worst case scenario for an ellipse will be the study of ellipse. The location of the center is actually at HK. They look similar except that the location of the center is actually at HK. Because on lesson number 19, the location of the center is actually at, sorry for this one, 0, 0. Okay. For tonight, the location of the center will be at HK. Okay. This location center 0, 0 and HK, they look similar except that there is a value for H and K for the topic this evening. Okay, let's try to bring out the two cases for study of ellipse with center at HK. For the study of ellipse, there are two major measurements, that is actually A and B. A and B. A is actually the major axis, the length of the major axis. It could be semi-major, right? Because it's only A. But if it's 2A, it should be major axis. And 2B is the minor axis, the length of the minor axis. Okay? So we remove the 2 for the meantime, we'll just concentrate on the value A and B. So there are only 2 measurements under ellipse, that is the length of the major axis, semi-major axis A, and semi-minor axis B. And for it to be an ellipse, A is always greater than B. Okay? It's an easy one because we just try to locate the, okay, I will try to remove the 0, 0. That was the past topic. If we could pinpoint the location of the center at HK, and we know the value of the semi-major axis and semi-minor axis, we could bring out the equation of that ellipse. So, under case number 1, if the major axis is along the x-axis, along the x-axis meaning along the horizontal. The longer length A, semi-major axis, is along the horizontal. This will be the equation. This is the equation. Okay? So this will become x minus h quantity square over a square plus y minus k quantity square over b square, and this should be equal to 1. The sign here should be plus for an ellipse. Because just in case this is minus, it's not an ellipse. That will be a hyperbola. That will be our next topic maybe. Because I'm just discussing the topics under analytic geometry gradually. So we are still an ellipse. Like what I said, if this is minus, it's not an ellipse. It should be a hyperbola. But for the meantime, since this is plus, it is an ellipse. So this is the equation of an ellipse. Okay? The location of the center is at HK. Okay? And the major axis is along the x-axis. So if we try to bring out the figure for this one, it is this. Okay? This is the y-axis. This is the x-axis. The location of the center is not at 0, 0 because 0, 0 is actually this one here. This is 0, 0. The last topic, the location of the center is actually at this location here. But for the topic tonight, for the first case number 1, this should be this will be the location of the center. It is at HK. Okay, I just bring out that the location or the figure for the case number 1 lies on quadrant number 1. It could take quadrant number 3 maybe, quadrant number 3, or quadrant number 2, quadrant number 3, quadrant number 4. It is just for simplicity. I just put it on quadrant number 1. Just to show you that the location of the center is actually at HK. So if we try to bring out the figure, since A here is greater than B, and for case number 1, the major axis, semi-major axis is actually along the x-axis, so this is actually A. And this is A. The smaller dimension B is actually this is B, and this is B. So as you can see it, the longer length A is actually this total distance here, 2A, that's 2A, and this is 2B. And this 2A here is greater than 2B. Okay? Like what I said, that the major axis is along the x-axis, so this total length 2A is along the x-axis. So this is the corresponding figure. I place the designation of the points. This point here should be focus number 1. I didn't place the coordinate. It is just for simplicity. Sorry, I think I cut my... No, it's not. It hurts a little. This is focus number 2. This is vertex number 1. And this is vertex number 2. I didn't place anymore the corresponding coordinates, but it's easy to place when we are solving problem. But for tonight, it is just for simplicity for the figure. I just place this one as focus number 1. This is focus number 2. This is vertex number 1, vertex number 2, and this is the center. And the equation of this one is actually this equation here. Equation number 1. That is x minus h quantity square over a square plus y minus k quantity square over b square, and this should be equal to 1. If this x here is the underneath of this one is a, we could say that the major axis is along the x-axis. So if this is x, this should be a. We could say that the major axis is along the x-axis. Okay? That's case number 1. For case number 2, if the major axis is along the y-axis, This should be the resulting equation. I think I needed another new what do you call this pen. That's the equation. It is almost similar to case number 1, except that the location of the major axis is underneath the y, for it to be the major axis to be along the y-axis. So we interchange the location of this one. We maintain the x and y, but we interchange the location of a and b. So for case number 2, this a here should be under the y. So this is now a square. B square goes here, and we could say if this configuration, it falls under that the major axis is along the y-axis. And still, A is greater than B. For the resulting figure, I bring out the figure to be under quadrant number 4. So this should be the x-axis, this is the y-axis. Like what I said, the major axis for case number 2 is along the y-axis. So this is 2A, and this is 2B. The longer length 2A is along the y-axis. That's why I said the major axis is along the y-axis. So for the points on the ellipse, it's just the same as this one. It's just that this is vertically erected. So this is the center. This is focus number 1, the upper one. This is focus number 2, the lower one. Vertex number 1 is the upper one. Vertex number 2 is the lower one. And just to repeat it, ellipse is actually the locus of points or path of points, and which is equidistant from 2 fixed points at any given time. Okay. This is an ellipse, focus number 1, focus number 2, focus number 1, focus number 2. At any point, at any intermediate point on the ellipse, okay, its distance from focus number 1 and number 2 is always the same. So if we try to get this point here, this distance here is same as this. So if the point moves here, this distance here plus this will be equal to the first distance, this one here and this one. That's an ellipse. So as the point moves, its distance, the sum of its distance from that two focus points are always the same. So we could say that it is an ellipse. That's the definition of an ellipse. Okay, I will try to give you a bonus topic on this ellipse here. This will be an advanced thing already because this will now be the study of a circle. But actually, the derivation of the equation of a circle actually emanates from the concept of ellipse. Okay, bonus points. If we try to bring out the equation of a circle with center at 0, 0, okay, so we are solving for the equation of a circle with center at 0, 0. We start with this equation here. This was actually lesson number 18. Lesson number 18 is actually the equation of an ellipse with center at 0, 0. I just got the first one to be the major axis is along the x-axis. Okay? Even though we get the other one, it will still be the same, but I prefer that the major axis should be under the x-axis or along the x-axis. And the equation for that one for ellipse, for lesson number 18, okay, because if we try to bring out the equation of a circle with center at hk, we will start with the equation of an ellipse with center at hk. So I will start with this one, x squared over a squared plus y squared over b squared, and it should be equal to 1. Actually, the center of that ellipse is actually at 0, 0. Major axis is along the, this is x, this is a, it is along the x-axis, right? And to derive the equation of a circle, like what I said, this is bonus. I mean, because this is now a topic on circle, but I will just want to emphasize that the study of the concept of circle actually emanates from the study of ellipse. Okay? So for a circle, for this equation here, to fall under the study of a circle, we will let A equal to B equal to R. R is actually the radius. Because the only, what you call this, the only measurement for a circle, okay, will be the radius. Or it could be the diameter. Okay, but under the study of analytic geometry, what is involved on the equation is actually the radius. So to derive the equation of a circle with center at HK, we will start with the study of the ellipse. Like what I said, it will be under x square over a square plus y square over b square equal to 1. And for it to be a circle, A will be equal to B equal to R. So with this condition here, if we try to substitute this condition here back to the equation of the ellipse, what will come out? X square over A square plus y square over b square, but A is equal to B, so we could replace this B here to be equal to A. So instead of placing B, we place A, and this should be equal to 1. Okay? So this is now algebra, right? There is an A square at the bottom. The right hand side is 1. So if we will try to multiply all the terms by A square, this cancels. And 1 times A square will be A square. So what will remain on the left will just be simply X square plus Y square equal to A square. And for it to become an equation of a circle, we will place the value A is equal to the radius. We'll just place A equal to R. So it will become X square plus Y square. So instead of placing A, because A refers to ellipse, right? So for it to be a circle now, we will replace that A by R. So it will become X square plus Y square equal to R square. And this is actually an equation of a circle with center at 0, 0, okay? And its dimension are all around, okay? Is actually R equal to the radius. So if we try to bring out the figure, it will be this, okay? This length here is same as this one, or this length here is same as this one here is same as this one, and we call it circle. So the emanation, or where this equation came from, actually emanates from the equation of an ellipse. So actually the first topic on the study of circle, that is this circle with center at 0, 0 and with the value radius R, is the equation is actually this one, X square plus Y square equal to R square. That's a bonus topic for tonight. Okay, that's it guys. So for those of you who would like to watch my channel, you could watch my channel. My channel comprises of long video format discussions. I got 10 subjects already uploaded. It's a complete topic from differential calculus to advanced math, plus these 2 topics here, analytic geometry, and the other one is, what's the other one? This is circuit. I uploaded 10 subject matters already. It's a complete syllabus. So for those of you who would like to watch my channel, you can get something from it. So if you would like to subscribe to my channel, you can subscribe it. My channel is actually at youtube.com/@proofdavidj. And if you want to share it, please click share. Good morning from Los Angeles.